All right, problem 2 on the FRQ. For time t is greater than 0, a particle moves in the xy plane with a position xt and yt and velocity vector t minus 1 e to the t squared sine t 1.5 exponent at the times equals 0. The position of the particle is -2, 5. Problem A. Find the speed of the particle at time t equals 1.2. Find the acceleration vector of the particle at t equals 1.2. Alright, so for 2A, you start off by writing out the speed equation, which you plug in the 1.2 into the t right here. So you could do square root 1.2 minus 1 e to the 1.2 squared t, and then you put all this squared plus sine 1.2 to the 1.25 squared, and then you plug that all into your calculator, and then you would get all these digits, and then you would square root that, and you get the answer of 1.271. And that will be worth 1 point for writing out the equation and solving for the answer. So for the second part, you would to find the acceleration, you would take the derivative of this, and then you would plug in the 1.5. And then you would plug it into your calculator, and then you would get the answer of 6.247 as the first point, and then second point would be 0.405 for the acceleration, and you would get a total of 2 points for part A. All right, part 2B. Find the total distance traveled by the particle over the time t interval 0 to 1.2. All right, so first we're gonna set up an integral from 0 to 1.2, and then we're gonna use the x and the y. So I'm gonna just simplify this out and just do this squared plus y squared. And then I, type this into my calculator. To get the answer, and I got an answer of 1.01. I guess you could add no 0, but 1.01, and that is worth a point. Writing this out is worth 1 point, and then getting the answer is worth 2 points. So this is worth 2 points. All right, 2C. Find the coordinate of the point at which the particle is the farthest to the left at t is greater than 0. Explain why there is no point at which the particle is farthest to the right at t equals 0. All right, so we'll start by writing off the equation for x, which we are using this right here. And then since we're using t equals 0, we'll set this equal to 0. And setting it equal to 0 scores 1 point. All right, then we'll set an integral using the positions -2 and 5. From 0 to 1, we would use x squared. We'll just sub in this into here. So x prime dt. And then you would plug it into your calculator. And then I got -2.603. And then you do the same for the 5. So 5 plus integral 0 to 1. And then we use the y instead of the x. dt. So we're using this. And then once you plug it into your calculator, you would get the answer of 5.410. And solving for both the leftmost coordinate positions would get you 2 points. And then writing out the coordinate pairs would also get you another point. All right, and next, a justification. So because because xt is greater than 0, the particle moves to the right for t is greater than 1. So let me write that out. The particle moves to the right because t is greater than 1, right here. All right, using what we did in 2C over here, we could therefore point that there is no farthest point to the right. So let me write that out. Therefore, there is no point at which the particle is farthest to the right, using this right here because there's no particle farthest to the right. All right, writing out the explanation will also get you a point. So in total of A, B, and C, you would earn a total of 9 points, 2 from A, 2 from B, and 4 from C. All right, number 4. A cylinder barrel with a diameter of 2 feet contains collective rainwater as shown in the figure above. The water drained out through a valve not shown at the bottom of the barrel. At the rate of change of height h of the water in the barrel with respect to time t is modeled by dH dt -1/10 square root h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with the radius r and the height h is V equal to pi r squared h. All right, part A. Find the rate of change of the volume of water in the barrel with respect to time. When the height of the water is 4 feet, indicate units of measurement. All right, so we first start off with the volume equation. Volume equation. V equal to pi r squared h, which is what they gave us right here. And then also pi, which is equal to the radius, which is 2 feet. That's the diameter, but the radius is 2 feet, so that'll be 1 squared h. And this is our volume equation right here, and this is worth 1 point for writing this out right here. All right, using the height given to us, where is it at? Right here, we're gonna take the derivative with respect to time and volume. So we do dv dt equaling pi, and then use the, since there's one, use the respect for the height, which is h equaling 4, 1/10, this equation right here, 1/10, and then you plug in the 4 for the height, and then you solve that. All right, since this is a no calculator question, I would have to use my mental math, and I did all this already, so I got a negative pi over 5 cubic feet per second. And then solving for the equation and getting the answer will be worth two points. So solving the equation will be worth 1 point, and getting the answer will be worth another point. So that's 2 points for A. All right, 4B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. All right, so for 4B, they want us to, there is a rate of change of the height. They want us to find the rate of change of the height with respect to time. So we're also going to have to use a dH dt and the dt dt, the dH dt and the dH dt. Okay, so we'll start off with the dH dt multiplied by this right here, with respect to time. So equaling dt dt. All right, so you start off with the equation, and then you start plugging in the numbers like the dHdt, which we plug into here. So that would be -1 times -20 screwed h. And then you plug in the 4 into here, and then you would get an answer of 1/20. All right, we're trying to find if the rate of change at 3 feet with respect to time t is increasing or decreasing. So we're trying to see if it's a positive or a negative number. Since we got in a positive number, I would say that the rate is actually increasing instead of decreasing. So let's see. So because 1/200 is greater than 0, the rate of change of the height at 3 feet is increasing. All right, so writing out the equation, the dH dt equation would be worth 1 point, and then solving and getting the answer, which would be worth another point, and then writing the justification for increasing or decreasing, which would be worth another point. So 4B is worth 3 points. All right, 4C. At time t equals 0 seconds, the height of the water is 5 feet. Using separation of variables to find an expression for h in terms of t. All right, so you want to start with using the separation of variables with this. So we'll probably split the dt, multiply the dt by both sides, and then put it on here. And then you would divide the root h from here, and then you would put it on this side. So I'm going to write that out real quick. So 4C, separation of variables. So you would put the dh right here, dividing by root h, equaling 1/10, -1/10 dt. After you do that, you would take the antiderivative of both sides, after you take the antiderivative of that, you would start to integrate. So you would get a 2 root h, and the integral of that would be 1/10t plus c. And then you would try to solve for c. All right, so solving for plus c, you would plug in the 5 into the height, and then you would plug in the t equals 0 into the time. So you would get 2 root 5 equaling, this would be 0, basically. This would just cancel out to 0. So you would get 2 root 5 equals c. And then after solving for c, you would plug the c back into the original equation. So equaling -1/10t plus 2 root 5. And then while solving for h, you would cancel out the 2's. So you could get h by itself. So you would cancel out the 2. So it would be root h equaling 1/20t, and then the 2 will cancel out. So plus root 5, and then you would square both sides. So you would get h equaling 1/, I think you would actually just square everything instead to make it simpler. All right, let me actually just rewrite this because I don't think you could really see it. So h equals -1/20 plus root 5 squared. All right, so for part C, the total will be worth 4 points. You will get 1 point for doing the separation of variables right here, and then you get another point for taking the antiderivative, and you get another point for solving for C, and then you get another point for solving for the answer, which is this right here. So the total of 4 will be worth 9 points. You get 2 points from part A, and then you'll get 3 points from part B, and then you would also get 4 points from part C. So if you get everything correct, you get 9 points. All right, for the multiple choice, I'll just give you the answers since I may not have that much time left. All right, for 77, the answer is D, 22.583. For 86, the answer is A, -4.